Hey guys, I know I'm not here this week, so I want to take a few minutes to visit with you guys, and then I'm going to actually do the lesson all on this video. This is Algebra 1. There is actually a QR code on some of the latter pages of this, so if you want to go and watch Chris Jones teach it, you can do that as well. I'll be back next week. What I want to do though today is go ahead and talk to you a little bit about the things and expectations for this week. One is that our mission will still be on Thursday. I've got it already set that it will go live on Thursday. There will not be a code on it, so you don't have to worry about getting locked out, things like that. But because I'm not here, there will not be any retakes until maybe next week. But I need you to remember this. This is the final grade before the end of the 9 weeks exam. So this will be calculated in to determine whether or not you have to take the test. So you want to try to do your very best on this stuff. Next week is the end of 9 weeks review, and that is going to go live on this Wednesday. The reason is because everyone, even if you're not required to take the exam, is required to do the end of 9 weeks review, and it's a much longer level. So because it's a longer level, I'm giving you extra days to work on it. Because it's a longer level, it's going to be worth 100 points instead of the normal 20. That's 5 times the normal amount. So you don't want to slack off and not get this stuff done. It is absolutely important for your overall grade, even if you're not required to take the end of 9 weeks exam. So take that stuff seriously. That end of 9 weeks level covers the entire 9 weeks. So all the way back from level 9 through this level 16, there's stuff on there. So I don't want you to be overwhelmed by it, but I do want you to be prepared for it. Like I've been saying this whole year, this whole first semester, I understand not everybody's going to be good at algebra. A lot of you probably won't use it. A lot of the stuff, I won't say all of it, a lot of the stuff that we do, you won't use it in everyday life, but it is a requirement for you to pass high school. And in addition to that, it helps you understand the world a little bit better. It requires you to think. There are so many things in this world that don't require us to think. And so, it's good to have to think every once in a while to make our brains turn on and operate correctly instead of just chat GPTing everything and Sora and everything and TikTok and everything. You be the thing that you use every once in a while. So we're going to do this together. I'm hoping that I can get this done in one class period. The notes for 16 are kind of long. Also, some of it piggybacks off of what we did last week, but other stuff is kind of standalone. So we'll kind of talk about that as we go through it. So go ahead and get your stuff. Obviously, I don't have bullseyes for you. Printer's still broken. So I'm not going to require that of you for these last few levels. So let's go ahead and get to it. We're going to look at Algebra 1, Level 16 Guide. All right, so here we go. We're going to start off here with a little bit of vocabulary. I'm going to try to keep things on the screen as best as possible. We're going to talk about a monomial. Now this is, I want you to think about all your prefixes here. We have mono, we have bi, we have tri, and we have poly. And that's going to kind of help you out with these vocabulary things. A monomial, you may have heard of like a monorail. I'm up here on Thanksgiving break working on this, and the bells are still going. So I apologize for that. There'll be another one here in a few minutes. But a monorail, or if you guys fish, monofilament line, it means one. So it's an expression with one term. A binomial, probably a little bit easier for you, like a bipod, would be an expression with two terms. And so when we're talking about terms, we're talking about any little pieces. I know we use pieces a lot whenever we talk about this stuff, so looking at two pieces. Trinomial, obviously, three, like a triangle. is an expression with 3 terms. All right. And then a polynomial. Now, you guys may think of poly, maybe like a polygon, or if you guys are interested in any language, maybe you've ever watched any of those videos of the internet of guys that just talk a whole bunch of different languages and really blow people's minds, which is pretty funny. Those guys are called polyglots. Means that they can speak a lot of languages. And so a polynomial is any expression with more than one term. So binomial is a type of polynomial, trinomial is a type of polynomial, and then anything over that, rather than going to quadnomial and quintinomial and sexnomial and all these different things, we just call them polynomials and keep it a little bit more simple. So when you simplify a polynomial, basically it goes back to what we call the CLT, combine like terms, CLT. We put all the things together. And then we start with the thing that has the biggest degree. So remember, degrees are what we call our little exponents. So we go the largest exponent, we put all those together. Those are like terms. So your x squareds would be like on a regular trinomial, x squared would be your biggest. And then you go x, and then you have your regular number that doesn't have any kind of variable on it. So we put those. So it's the size of your exponent piece. So let's look at an example and maybe it'll sink in a little bit more. So what this example is we have this problem right here. I'm going to try to get it up a little bit better for you on the board. We have all these different pieces. Obviously, this is a polynomial. What they're wanting us to do is combine like terms here. They just want us to CLT this. They want us to combine like terms, and so we're going to put things together. So again, we can kind of go through. The first piece is a number piece. Do I have any other number pieces in here? No, 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 yes. So I have 2 and a -4. 2 and -4 together is going to be -2. I know that's going to be my smallest piece because the other pieces have x's and cubes and all that stuff that goes together. And so that's going to be, again, the smallest degree. I know that's going to go at the end. So let me look at what else I have. I have an x cubed, I have an x squared, I have an x cubed, and I have an x squared. So I'm just going to go ahead and build this from right to left. Just because I already started off on the right side, it doesn't really matter. You can go either way. So I'm going to combine my x squared parts here. So I have an 8x squared and I have a -6x squared. And so when I have an 8x squared and a -6x squared, and I put those things together, what I'm going to get is I'm going to get a 2x squared, because 8 minus 6 is 2. And then now I'm left with my 2x cubed pieces here, and I have a 2x cubed and I have a 5x cubed. 2 plus 5 is 7x cubed, and that's going to be positive, and this was already positive here. And so if I look at it, that's going to line up with C. So again, we're just lining up the two different things. If you like to fill in your blanks, you can do that here. 2 and then 2x squared and then 7x cubed. So 7x cubed plus 2x squared minus 2. And this is a polynomial. It's a trinomial technically because there's only 3 pieces in it. All right. So let's look at example 2. All right. So now we have just kind of a mixed up polynomial right here. We have -9x squared minus 5 plus 8x squared plus 3. So I just have really 2 types of pieces. I have the number pieces, and then I have the x squared pieces. And so I'm going to put those together. And so I'm going to have -9x squared plus 8x squared. -9 plus 8, subtract 9 from 8. And I'm going to keep the sign of the larger one. And so I have -x squared. And then I have -5 plus 3. And so again, I have a larger piece. So 5 minus 3 is 2. So I have a -2. And so that's going to be B. These things aren't really hard. They just look complicated. Remember, when we eat an elephant, we just do it one little bite at a time, and you'll get through it in no time at all. So I'm going to leave that up there for just a second longer for those of you that are copying. And we'll flip it over and look at the next page. All right, so let's look at example 3 up here. This one, it's the same type of problem. They just add one more step to it. Essentially, you just work the things that you know. All this stuff, again, is just being built off of things that we know. So I have a -5 times -x minus 2x cubed plus x plus 4x cubed. Now, what we'll do is we'll just distribute it into the parentheses. Now, if you wanted to, you could absolutely simplify the inside of the parentheses. We could combine some things together, which we can do that. And I'll show you both ways that you can do it and show you it makes the same answer. But what we'll do is we'll just go ahead and distribute that 5 through. And then from there, we'll put combine all of our like terms. And so what we get is we get 5x, because we're bouncing this to everything. Remember, we're just bouncing it to all of it, to every piece that's inside there. So I have 5x, because negative times negative is a positive. And then I have plus 10x cubed. And then I have negative 30x, because negative 5 times 6 is negative 30x. And then now I have a negative 5 times a 4, which is negative 20x cubed. So now I'm going to combine my like terms. And so I have a negative 20 and a 10x cubed. Both of these pieces here will go together. And so I get a negative 10x cubed. And then I have a 5 and a negative 30. So 30 minus 5 is 25. I'm going to keep the sign of the larger, so I have negative 25x. So let's look up here. It's not that one. Oh, nope, it's not that one either. It is this one. It is C. Just to show you that you can go ahead and combine your like terms, you could put so if I'm looking here, I'm going to combine these things. So I'm going to put the x's together and I get 5x. And then I'm going to put the x cubes together and I'm going to get a negative 2x cubed plus 4x is negative 2x cubed. And I can multiply all that times negative 5 and I wind up with this simplified. So either way, you can do it either way. It doesn't really matter. Whichever way makes more sense to you, but either way is acceptable. All right, let's look at example 4. I'm going to leave that there for just a second more if anybody wants to copy that top piece again. Okay, let's look at the bottom, this example 4 here. Okay, I got a lot of p's in here, and I've got kind of the same thing going on here. So if I look at everything, I've got a 32p minus 4p cubed plus 9p squared plus 16 minus 4 times p cubed plus 8p plus 4. So I'm already knowing I have to distribute because I cannot simplify anything inside of that. So what I'm going to go ahead and do is I'm going to do that part first. I'm going to go ahead and go negative 4p cubed. And then I'm going to go negative 32p, and then I'm going to go negative 16, and that's that. Then I'll just copy everything else on here, starting with, so this takes care of that. All this is right here. So now I have 16, 9p squared plus and then negative 4p cubed, and then 32p. So I've just basically copied everything down, and then this piece right here starts right there. Just combine your like terms. I'm going to put the p cubed is the biggest part, and so I have 2 negative 4p cubed, so that's going to give me a negative 8p. I don't know why I'm writing my p like that. P cubed, there we go. And then I've got a 9p squared, and I don't have any other 9p squareds, right? So that's just going to come down 9p squared. I'm going to go ahead and cancel these out, just show that I've put those down there, keeping track of everything. Now I've got the p parts. So I have a 32p and I have a negative 32p. Well, those two, that adds up to 0p, so I'm not going to write that down because those cancel out. And the last pieces I have to mess with are my whole number 16 and negative 16. Well, 16 minus 16 is also 0, so I don't need to write that down. I just need to cancel it out. And so my answer is negative 8p plus 9p squared, which is D. All right, let's look at example 5. Okay, so on this one, it's actually a little bit more simple, and this is actually just a subtraction deal, and I'm going to show you another way to do this here in just a minute. But what we're going to do on this one is we're going to do the flip the sign, because here's just, I can't simplify anything in here. I can't simplify anything in here, but I have to deal with this negative sign. So remember, when we have a negative sign in front of it, you can remember one of two ways. The first way is I just remember I'm going to flip the sign of everything in here. So this is going to become a negative 3x squared plus 6x plus 1. If you can remember to do that, that cuts down on some steps and that makes things easier. If you can't remember that, you always need to remember that this negative is really a negative 1, and then it turns into the distribution, just like what we've been doing. So negative 1 times 3x squared is negative 3x. Negative 1 times 6x is positive 6x. Negative 1 times negative 1 is positive 1. So that's why it is. So because I know it, I'm going to just go ahead and do the flip the sign thing. And so I'm just going to drop my parentheses and flip the sign. So I have negative 5x plus 5 minus 3x squared plus 6x. This is where we're flipping the signs, plus 1. And now I'm just going to combine my like terms. So my biggest degree, remember our degree is the negative 3x squared. I don't have any other x squared, so I'm going to leave this negative 3x squared. Then I'm going to combine. So I'm going to just mark that out so I know I'm done with it. I'm going to combine these two. So I have 6x minus 5x, which just gives me a plus x. And then I have a 5 and a 1 that I'm going to put together, and that's going to give me a plus 6. And that is simplified because I can't combine anything else. So that is my answer right there. Okay, so we did a subtraction of polynomials basically. Now I'm going to show you a little bit different way. This might be easier for you. It might not. But we're going to look at a couple different ways that we can simplify and find the sum and the difference of polynomials. So we're going to look here at example 6 on the next page. Okay, so one of the ways that you can do it is you can just line up your like terms. But to be able to do that, you have to make sure that they're in the proper order of degrees. So I've got an x squared, I've got an x, I've got a number, I've got an x squared, I've got an x, and I've got a number. And so basically all I'm going to do is I'm going to take this part right here, and I'm going to rewrite it right underneath it exactly how it is. So negative 3x squared minus x plus 7. And then we're just going to add all the like terms up because I've lined them up right there. We're just going to add them up. So I have plus 16. I have minus 7x. And then I have minus 10x squared. Remember, when you're adding these things together, you're not doing anything with your exponents or your variables. You're just adding and subtracting the coefficients. So that's pretty simple. Now this one is subtraction. So this is sum. Sum means adding. If you don't remember that, write it in. Subtract. We're going to subtract this from this. So I need you to understand we're subtracting this thing from this thing. So what we're going to do is we're going to say I'm subtracting this from that. So I'm going to do the whole minus negative 2x squared minus 4x. Okay, y'all remember we just literally did this, and what does it do? It flips the sign of all this. So I'm going to line up. Now you notice this only has 2 pieces, and this one has 3, but that's okay. We can line that up. So this is going to be plus 2x squared plus 4x, because the negative sign flips everything inside of there. And now I'm going to take this and write it right underneath here. I'm going to put the 2x squared, that's plus 2x squared, and then the 4x plus 4x. And then there's nothing to write here, so I don't need to mess with that. I'm just going to bring that 5 straight down. So it becomes negative 5, and then this becomes 4x minus 2x, so it becomes plus 2x. And then these two are going to add together, and so I'm going to get 4x squared. So understand that, read it carefully, subtract this from this. So this is what I'm going to start with. If you go this from this, you wind up with the same numbers, but everything's flipped. So if you did that, you would have negative 4x squared minus 2x plus 5, and it's wrong because you didn't subtract in the right way. So make sure you're paying attention to that portion of it. All right, I'm going to slide that up so you can still see that if you're writing. And so let's look at the next part. We want to write it in a polynomial in standard form. Standard form is just a fancy way of doing what we've already been doing, which means that what we're going to do is we're going to put it in order with the largest degree piece first, then the next largest, then the next largest, and so on until we've run out of pieces. So what we're going to do here is kind of like FOIL. It's very similar to FOIL here, because we're just going to distribute the 3x to everything here, and then we're going to distribute the 2 to everything in here, and every time we do one, we're going to just write that over again. So I'm going to go 3x times 3x squared, 3x times x, 3x times 4. And then I'm going to go down here on the bottom, I'm going to go 2 times 3x squared, 2 times x, 2 times 4. Now, when we multiply x pieces or y pieces or p pieces or whatever pieces that they're giving you to multiply together, if they're the same piece, really what it is we're adding the exponents. So a 3x times 3x squared is, I'm going to write it over here. I've got 3x times 3x squared. So I'm going to multiply the 3 times 3, and I'm going to get 9. You always just multiply your coefficients together. You multiply the number parts together. Now, when it comes to this part right here, think about it like this. I have 1x here, and then I have an x here and an x here. So it's x times x times x. So how many x's do I have here? Well, I have 3 x's. But it's not a 3x, it's x to the third power. So this becomes x cubed, because it's x times x times x. Not 3 times x, but x times x times x. So it's x times itself 3 times. So the 3x times the 3x squared is 9x cubed. And then I have the 3x times the x, same deal. 3 times 1 is 3. X times x makes it x squared, because anything times itself is squared, right? And then we're done with that one. Now I have the 3x times the 4, which makes it plus 3 times 4 is 12. I don't have an x to multiply at times, so I'm just going to leave the x on there. There's just one x left in that part. Now doing the 2 part, I have 2 times 3x. Well, this one's going to be easier because I'm just multiplying, because there's no x piece that I'm multiplying by here. I'm just going to multiply the 2 times all the exponents, or all the number parts. So I have 2 times 3x squared, which is going to give me plus 6x squared, 2 times x, which is going to give me plus 2x, and 2 times 4, which is going to give me plus 8. Now I'm just combining the like terms again. I only have one x cubed piece, so I'm going to write that here, 9x cubed. I'll mark through it. I have 2 different x squared pieces, so I'm going to put them together, so I get 9x squared. I'll mark through those pieces. I have 2 x pieces, So I'm going to put those together, 12x and the 2x, and that's going to give me 14x. I'm going to mark through those, make sure I'm done with that. And then I just have one number piece, which is my 8. So I'm going to write that there. And so my answer is 9x cubed plus 9x squared plus 14x plus 8. Again, I know it's a lot, but you can't eat an elephant in one bite. Just do it one little bite at a time, one piece at a time. All right. This next one is one that, a great example. It's exactly like this top problem, just with different numbers. So here's what I want you to do. I'm going to set a little timer on my watch. I'm going to give you like 2 minutes. I want you to work on this one. I want you to work on this one on your own, and then I'll put the answer up here in just a second. So you don't have to pause the video. I'll just let the video run for 2 minutes and I'll put the answer up. I may sing you a song or something while you're working. Just kidding. I'm not going to do that. You're welcome. Remember, it will be helpful if you draw all your little lines, all your little rainbow lines that go through there, so you know what you're multiplying by. Don't forget your negatives. I'm still here. You're still working. You're almost done, or if you're done, good. If you're not, you still got about a minute. Keep working on it. All right, let's take a look at what you got. Hopefully it matches up with what's up here on the board. Remember I said do your little arcs, your little rainbow pieces up there to connect all your little parts together. And so you get negative 3x cubed minus 18x squared minus 12x plus 7x squared plus 42x plus 28. Combine your like terms. There's only one cubed piece, so it's going to be on there by itself. Combine your 18 and your 7, you get a negative 11x. Combine your 42 and your negative 12x, you get a 30x, and then of course the 28 stands alone. So there's your answer. Hopefully if you didn't get that answer, you see maybe where you went wrong. Be careful with the signs. That can be a big part of it. It's a struggle. I remember I struggled with signs big time whenever I did this way back in 19-aught, whatever. It was a long time ago. All right, let's look at the next page. I know it's a ton of examples today. So my plan is to take this video that I'm making and put it on a YouTube, which obviously, if you're watching it in here, I've done that. If this goes long, I will split it, or I'll tell you to mark your time at the end of class, and then we'll pick it up the next day. But I'm going to go through this whole thing today and try to get through all these notes for you guys. So if you have to carry over a little bit into tomorrow, that'll be okay. You guys will be fine on getting all your stuff done. All right. So what these problems are is basically they're adding variables to variables. I know that's a good time for you guys. I know you guys really like that. I'm just kidding. I know you hate it, but you can do it. Basically, they're saying they want to write 2c minus 3b, but they're telling you what c and b stand for. So where you anytime when you have a problem like this, and it tells you this is what c is equal to and this is what b is equal to, what you're going to do is you're going to rewrite it. So they're giving me 2c minus 3b. What I'm going to do is they tell me to start off with this is c, so I'm going to write that here. They tell me that this is b, so I'm going to write that here. I'm going to leave my coefficients. So basically I'm going to get 2 times 1 plus 5n minus 6n squared. Notice that that's not written in standard form because it's backwards. So, but we're not worried about that right now. We'll write it in standard form whenever we're finished, okay? And then minus 3 times n plus 4n squared. All right, so I've just rewritten it. All I've done is I've replaced the c with what they're telling me c is equal to. I've replaced the b with what they're telling me that b is equal to. Now this looks like all the problems we've been working the whole time. I'm going to distribute on both of them. Distribute the 2 here. I'm going to distribute the negative 3 there. And then I'm just going to combine like terms. So we distribute. So let's do that. So I've got 2 plus 10n minus 12n squared, because it's just a 2 times everything. I'm not messing with any of the variable exponents. And then here I've got negative 3n minus 12n squared. Same deal here. It's just a negative. But don't forget to put that negative in there. So we're going to distribute, and now we're going to CLT. We're going to combine like terms. Remember, if I write it on here, you probably need to be writing it too. So when you go back, by the way, this is a great opportunity for me to tell you this. I'm not going to be here this week. So it's going to be really hard for you to ask me questions. And I really appreciate whoever's subbing on this class for me. And I'm not expecting you to be able to know all this stuff. That's why I didn't leave you all these notes to try to teach it yourself. Maybe I'm saying you're welcome. The thing is, this is where you go, and the examples and the videos on Delta Math are where you go if you get stuck. Remember, it's okay to struggle. Use all the things. What I don't want you to run the risk of this week is going into Google and just Googling the answers. I am aware, I'm not a stupid person. I know that some of y'all still do that, but you need to break that habit. That is not you thinking, that is the internet thinking for you. That is AI thinking for you. You need to learn how to think for you, because in the real world, we don't get to use AI to solve all of our problems. We have to figure them out on our own. So write down all the little notes, because whenever you get to a problem like this, you can go back and you can go, okay, I'm supposed to distribute. I'm going to write this in here, substitute, which is what we did here with the arrows. Substitute, then I'm going to distribute, and then I'm going to combine like terms. But they want it in standard form. They will ding you on your assignments if they tell you to write it in standard form and you don't. So I'm going to look at what's my biggest pieces. Well, I've got the n squareds are my biggest pieces. These are my 2 biggest pieces. So I'm going to deal with those first. So I have negative 24 n squared. I'm done with those. I'm going to cut those out. Now I'm going to look at the n pieces. I have 10n minus 3n. So that's going to give me plus 7n. So I'm going to cancel those out. I only have one number piece. I'm going to write that in here, and now I've written that in standard form. So it looks like it's going to be a lot. It's really not that bad. Just remember, standard form is the highest degrees first. So we're going to go highest to lowest degrees left to right. All right. So these aren't that bad. Next couple examples are really the same exact thing. Again, read your question, standard form here. They tell me what D is equal to, they tell me what C is equal to, so we're just gonna write it in. I'm gonna skip this part. I'm gonna skip that right there and just go straight to it. I'm gonna just do my substitution first. So I have 3 times, this is my D, 2 minus 9n squared, and then minus what C is equal to, which is this right here, minus n plus 3 plus 4n squared. Okay, so I'm going to distribute here, and then technically I'm going to distribute here, but what else can I do if I remember? I hope somebody just said flip the signs, because that's what you can do. You can just flip the signs of everything inside of there and just rewrite it. So I'm going to distribute. So I have 6 minus 27n squared minus n minus 3 minus 4n squared. And so again, this goes back to, now I'm just going to put it in standard form, which means I'm going to put my n squared pieces. That's my biggest degree. I'm going to put that first. And so I have negative 27n squared and 4n, which is negative 31n squared. So I'm going to cancel out that. I only have one n piece, so I'm just going to write that in here. One negative n. Don't forget your negative sign. And then I have 6 minus 3, which is, right, plus 3. And that's my answer. We're just substituting. All right, I'm going to give you example 12 to do on your own. Again, I'm going to give a couple minutes for you to work on this, like 2 minutes to work on it. I'm actually, while you're working on this, I'll finish it too, and then I'm going to go actually check my time, see how I'm doing on my video, see if I'll let you know if I'm going to need to split this video or not. All right, so let's see, because we've got one more page of notes after this one, just one more. But the next page of notes actually does have the QR code on it, so you can watch that on your own. I know you can't have phones in class. I don't know if your Chromebooks will let you pick that up and do the video. If it does, great. I'll have to try that. I haven't tried that yet. But go ahead and work example 12 on your own right now. Okay, I'm looking at it. We're at about 38 minutes into this. We might be able to get through the next page. Nope, probably not. There's a lot of examples on the back. So I will probably split this into 2 videos for you guys whenever I edit it. So we'll get through this one today. Depending on the amount of time that you have left, we may go ahead and I'll let you start on it. If you have more than 10 minutes left in class, which it may be pretty close to that, go ahead and try to get some of your level done. If it's less than 10 minutes in class because there's been something else that's gone on, don't be a problem for the rest of class. All right, so let's look at this one. Example 12, just substitute in, and then we have the k minus k, 5k squared minus 1. You have the 3 times the k minus 2k squared. You're just going to distribute Remember, we substitute, then we distribute, then we combine like terms because it wants it in standard form. We're going to start with the biggest pieces first, and so you should get 16k squared plus 5k minus 2. All right, I'm going to stop this video. Tomorrow we'll have another short little video, and again, I'll be able to talk. I'll talk to you before we get going. So if you have time, if you have more than 10 minutes, go ahead and get Chromebooks. Try to get a couple problems done at least so that while it's fresh, and then plug those Chromebooks in when you're done today. Remember, don't just stick them in the cabinet. Plug them in the cabinet because everybody needs to use them. All right, y'all have a good one.